Hi, today's video is 1992 AB4, which was also #1 on the BC exam that year. And it's a fairly straightforward implicit differentiation exercise. For part A, they ask us to find dy dx in terms of y. So all we need to do is start with the original function, which is y plus cosine of y equals x plus 1. Don't forget the chain rule, so the derivative of y is y prime, but when we do cosine, it's sine of y times y prime because of the chain rule. Derivative of x is 1, and derivative of 1 is 0. They want y prime, so we're going to go ahead and factor out y prime and do 1 minus sine of y equals 1. And then to finish it up, all you need to do is divide by the 1 minus sine y factor, and you get 1 over 1 minus sine of y. And that's it. Now for part B, they are asking us to write an equation for each vertical line to the curve. So vertical tangent to the curve. So a vertical tangent means that y prime is undefined. And in this case, this is 1 over something, so we know that y prime is undefined when the denominator is 0. So that is equal to 1 minus sine y equals 0. Solve this, you get sine of y equals 1. Our interval was 0 to 2 pi. The only solution to sine of y equals 1 in that interval is y equals 2 pi over 2. Now, before you celebrate that you've got the answer and you put a box around this, remember that you are looking for the equation of a vertical line. Y equals pi over 2 is not a vertical line. That is a horizontal line. Vertical lines are always of the form x equals something. So we need to find x, and the way we do that is we take y equals pi over 2, plug it into our original equation, and solve for x. So I'm going to go ahead and do that now. So we have, going back to our original equation, I'm going to rewrite it a minute, equals x plus 1. And we just determined that y equals pi over 2. So you plug that in, pi over 2 plus cosine of pi over 2 equals x plus 1. Cosine of pi over 2 is 0. So I end up with x equals pi over 2 minus 1. And this is a vertical line, so that's the solution that we're looking for. And finally, we're going to do part C, which just asks for the second derivative in terms of y. So all we need to do is take the derivative of the expression that we already got in part A, which is 1 over 1 minus sine of y. So I'm going to take the derivative of that. Now you can use quotient rule on this. If you look at the College Board scoring guideline for this question, that's what they did in their solution. But I find it much simpler if you just do the derivative of 1 minus sine y to the negative 1. So doing that derivative, I get 1 minus sine of y negative to the negative 2 times the derivative of the inside, which is negative cosine of y times y prime because of the chain rule. The minus signs cancel, so you get 1 minus sine of y to the negative 2 times cosine of y times y prime. And the last step is to substitute y prime, which is just 1 minus sine of y to the negative 1. So I have 1 minus sine of y to the negative 2 times cosine of y times 1 minus sine of y to the negative 1, which is 1 minus sine of y to the negative 3 times cosine of y And if you want to write that in a more conventional way, you would just write cosine of y divided by 1 minus sine of y to the cube. And that's it. A fairly straightforward implicit differentiation problem from 1992.